Hi lads, in this video I'm going to go through how to find the true inclination of an oblique plane to the vertical plane and also the horizontal plane. So for the first one I'm going to find the true inclination of the oblique plane to the horizontal plane. So you take an XY line first. I'll show two methods at the one time for this. So method 1 and method 2, which is on page 233, that would essentially. So it actually doesn't give you any angles, but in the video that I would have released previously I would have said that they were set at about 45 and 30. So I'm just going to set an angle there of 45 degrees and an angle here at the bottom going at 30. And I'll just label that there as my vertical trace, or not VP, vertical trace and horizontal trace. So the idea I was telling you about was based on the cones. If you watch the other video, it'll actually show you how to do it. So the first thing you do is you pick any point along this here, and that will determine basically the size of the cone that you would have seen in the book and also in the video. So if I just pick, for example, this point here, I have to go perpendicular to my horizontal trace. I'm going to find the true inclination to the horizontal plane, so I look along the horizontal trace there, looking perpendicular. And I get my point there on my XY line. I take that straight up, and that will give me the height of my cone there. So what I want to do is, I want to actually rotate that. As you remember from the video, if I look in here you can actually see the edge of that cone. So if I rotate that around, because the angle never changes in the cone, so I just draw the full base here. Or it's only half a cone in this situation. That will give me this angle here. And that angle there is the true inclination of the oblique plane to the horizontal plane. So just write that in there. So the true inclination of oblique plane to HP, the horizontal plane. That's the true inclination there as a result. Also, if I connect here to here, it's also going to be the same thing, just rotating around this side instead, because that distance from there to there is the exact same as there and there. I can show that in colour as well. So all I'm doing is basically rotating it around so I can see it as a level line. So them two distances are the exact same, and also that green distance there is also the exact same. Alternative method, which would have been seen in the video as well, is basically where you look along the actual horizontal trace and see it as a point. So the idea would be, if you just set square here, for example, it might be hard to see when it's set up this way with the visualizer. But if you were to look along that edge there as an actual and see it as a point, the angle in here you'd see would be the actual true angle, is what we're actually trying to figure out. So what we do is we look along it just like you would with any other auxiliary, and then you draw your XY line perpendicular to that. Just like that there, there's your X1, Y1 line. And what you do is you pick a random point along it. So let's just say I pick this point here on my XY line. I take that out as well along the auxiliary view. Remember, for an auxiliary, when we're taking it for an auxiliary elevation, we always take our heights from our heights from our elevation. So that height there, we take that. We apply it to here. And you'll find that that angle there is also the exact same as that angle and that angle as well. And that's also the true inclination. You can see that there. It's also the exact same, so just let it focus. So both of them are showing the true inclination, and just two different methods of actually solving it. So what I've done basically is just shown in yellow. I've taken this height here and I've marked it up there. So basically where that point is in the XY line, take it up and then take that height there, we'll just call it H there and H there. And that's to give you the true inclination of an oblique plane to the horizontal plane. Just pause the video there for 1 sec and just get a new sheet just to do the other one then. So for the next one we're looking to find the inclination of an oblique plane to the vertical plane. So same idea again, draw our XY line and we'll take the exact same angles again. So I'm going to take my 45-degree line going up, just take that up there, and then just take 30 degrees going out this way. And once again label your actual traces, your horizontal trace and your vertical trace. And this time we're trying to find the true inclination of an oblique plane to the vertical plane. So this time we're going to be focused on the top half area using the vertical trace. With this being set at 45 degrees, we just pick a point randomly along it again, which is going to determine the size of our cone. So if I just take that point there, I take it in perpendicular to my XY line. I take that straight down. That will determine where the apex of my cone is when it's lying down there. And then what I need to do is rotate it into position. So I'm taking that distance there, rotating it down so I can see the true angle. And that gives me the true angle there. And the exact same can be done if I rotate the cone around this way. When I connect these two here, you can see the cone. There's the true inclination of it there as well. So basically what I'm showing is, if I use the green as well, that this distance here is the exact same as this distance here and here, and that's showing the true inclination being made to the vertical plane. So you remember from the video as well, you would have seen it. And also just get the picture up here. You can see there what I'm actually doing, rotating the point down and connecting it. You can see the angle there and there is the exact same. So it's just based on a cone again, because a cone fits perfectly inside the shape against the plane. So the alternative method, just like the last time, where we would look along the horizontal trace to find the true inclination to the horizontal plane, we look along the vertical trace. We want to see that line as a point so you can see an edge view of it to draw the true inclination. So we extend out our vertical trace and we draw our x1, y1 line once again. There's the point I would have picked. So I go there, out that distance there, and remember, instead of taking my height up, I take my distance from my XY line down because it's an auxiliary plan. I get that distance there, step it out to there, and then you'll see that this angle is going to be equal to this one and this one as well. So it's the exact same. And I'll just put that in there again. So the true inclination of oblique plane to the vertical plane, so VP. So that's showing that there, and so I'm showing it out here as well. And just once again, I'll just use yellow to show the heights I'm taking for the second method. So that distance there in H, and we extend it out, we apply to that distance there as well, so them two are equal. So hopefully that video helps anybody who may have been stuck on that part.